Hello, onto our last lesson of algebra, looking at addition and subtraction of algebraic fractions. Now, obviously, as you would know since year 7, when adding and subtracting fractions, you must have common denominators. So, must have common denominators. Okay, let's go through the first couple of questions. Okay, x plus 7 on 4 minus x minus 3 over 6. Now, obviously, these are not the same, but 4 and 6 both go into 24. Actually, 12 is even better. 12. So that's times the first one by 3, and the second one's by 2. We're going to get this. 3, x plus 7 on 12, take away 2, x minus 3 on 12. That's going to be 3x plus 21 minus 2x plus 6 on 12. Like terms, the x's, that'll be x and then plus 27 on 12. Obviously in this question, be really careful of the minus, so minus 2x, but plus 6, really important. Okay, on to question 2. We have an x squared and an x, so let's times the second one by x, so they're both x squared. 8 on x squared minus 3x on x squared, that's just going to be 8 minus 3x on x squared. Also remember, when getting common denominators, you must times the top and the bottom, not just the bottom, otherwise you've changed the fraction. So every time, top and bottom. And also the first question, remember, when you're timesing two things by one thing, you're creating brackets as well. Okay. Here's another 2. Let's go through them. Start with question 3. So 4 over 3x minus 2, take away 5 over x minus 3. Now, our common denominator is actually going to be both of these put together. So on this fraction, I'm going to multiply by 3x minus 2, top and bottom, and on this one, x minus 3, top and bottom. Alright, and the next line, 4 x minus 3 over x minus 3, 3x minus 2, take away 5, 3x minus 2 on x minus 3, 3x minus 2. Again, just to clarify, for these to be the same, this must go to this side and this must go to this side as well, which gives us a combined common denominator. Now we can keep going to expand. 4x minus 12, take away 15x plus 10, because minus, over x minus 3, 3x minus 2, like terms, or 4x take away 15x is negative 11x, negative 12 plus 10, minus 2. And that should be my answer. Okay, question 4. This here can actually be factorized, so let's do that. 3 equals 5 on x plus 7 over x plus 3. Now to make these the same, just need to multiply these ones by x plus 3. That's going to give us 5 x plus 3 over x plus 3 plus 7 over x plus 3. Now at this point you might be thinking cross these off, but if you do that, you're just going back to the original question again. So let's keep going. 5x plus 15 plus 7 over x plus 3. That's going to be 5x plus 22 for x plus 3. Okay, next two questions. Question 5 and question 6. So question 5, 2 over x plus 3 x minus 1 plus 3 over x minus 2 x plus 3. So remember, we've got to make these both the same. So what does this have that's not here? We need to multiply by x minus 2. See how in this, there's no x minus 2. Now for this one, what does this have that's not here? And that would be x minus 1. We now have 2x minus 2 over x minus 2, x plus 3, x minus 1, plus 3, x minus 1 over x minus 2, x plus 3, x minus 1. So remember, we've got to make these both the same, which our common factor is now this, x minus 2, x plus 3, x minus 1. And whatever's not in each one, you multiply by that, but the top and the bottom by that same thing. Now let's keep going. So we're going to get 2x minus 4 plus 3x minus 3 all over x minus 2, x plus 3, x minus 1. Next step, so like terms, x's and the numbers. So that's going to be 5x, take away 7 over x minus 2, x plus 3, x minus 1. Okay, now question 6. You can probably factorise these first. So let's do that. So equals 5 over x, x plus 2, minus 2, x minus 2, x plus 2. So that's the difference of two squares. Now we're going to make these the same thing. So what does this have that this doesn't have? This needs an x. Now what does this have that this does not have? We need an x minus 2. Okay, equals 5 x minus 2 over x, x minus 2, x plus 2, minus 2x over x, x minus 2, x plus 2. Expanding, 5x minus 10 minus 2x over x, x minus 2, x plus 2 equals 3x minus 10 over x, x minus 2, x plus 2. So again, just to clarify, you've got to make these exactly the same. So one by one, think about in this, what is here that's not here, just the x, so times top and bottom by that. And this one here, what does this have that's not here, and that's just the x minus 2, so times top and bottom by that. You now have that same common denominator for each bit. And then from there, expands, simplify, and that's my answer. Okay, last question. Question 7. A minus 3 over a squared minus 11a plus 28. Take away a plus 4 over a squared minus 6a minus 7. So factorize these monic trinomials and see what happens. Okay, let's go through it. A minus 3 over a minus 11a 28. I believe that would be minus 4 and minus 7, I believe. We can check that. Minus 4 times minus 7 is 28. Minus 4 plus minus 7 is minus 11. Okay, and then minus a plus 4 over, again we're going to have two brackets. Alright, I believe it's minus 7 and plus 1. Again, to check that, minus 7 times 1, minus 7, minus 7 plus 1, minus 6. And again, just to clarify again with the cross method. A minus 7 and 1. A times minus 7 minus 7a. A times 1, 1a. 1a minus 7a is minus 6a. So these are my factorizations, which is what we have. Okay, next step. Look at this. What is here that is not here? We want the a plus 1. So times top and bottom by a plus 1. And then this one, what is here that is not here? We want the a minus 4. Okay, now let's expand. So it's going to be a minus 3, a plus 1, over a minus 4, a minus 7, a plus 1, take away a plus 4, a minus 4, over a minus 4, a minus 7, a plus 1. Okay, we're almost done. Now, at this point, I want to make a point that you can't actually cross off because you have a minus here still. So what we're going to do next is actually expand and hopefully clean it up from there. So here we're going to use FOIL, a times a times 1, minus 3 times a, minus 3 times 1. But I'll do that on my next slide. Okay, so let's do FOIL. So it's going to be a squared plus a minus 3a minus 3. Then minus, this is the difference of two squares. So minus a squared minus 16 all over a minus 4, a minus 7, a plus 1 equals a squared minus 2a minus 3 minus a squared plus 16 over a minus 4, a minus 7, a plus 1. Almost finished. So a squared and a squared cross off, because a squared minus a squared is nothing. Then we have negative 2a. Negative 3 plus 16 is plus 13, so plus 13 over a minus 4, a minus 7, and a plus 1. Okay, so that is my final answer, and that is the end of algebra as well. If you go to the previous slide, there's some questions to work on, but also keep an eye on Google Classroom as well. And I'll see you in the next video for the next chapter.